Welcome to ZoomInData. Hello everyone. Thank you for joining the 9th video in our comprehensive Azure Logic Apps series. In this session, titled Deployment, CICD, and Management Best Practices, we will cover how to deploy Logic Apps workflows reliably to different environments. Implementing CICD pipelines using Azure DevOps or GitHub Actions. Key management practices including monitoring, runs history, debugging, alerts, and operational excellence. Best practices for versioning, environment separation, and production readiness. This topic is essential for moving from development to reliable, scalable production deployments in enterprise scenarios. If you find this content valuable, please subscribe to ZoomInData and enable notifications to follow the complete series. What are the primary ways to deploy Azure Logic Apps? Azure Portal manual deployment for quick changes and prototyping. Infrastructure as code using ARM, Bicep templates for repeatable deployments. CI/CD pipelines, Azure DevOps, GitHub Actions, for automated, version-controlled releases. How does deployment differ between consumption and standard Logic Apps? Consumption. Deployed as a single resource. Use ARM templates or Portal export, import. Standard. Deployed as a full app, like Azure Functions. Supports multiple workflows, local development, and direct deployment from VS Code. Standard offers more granular control and better CI/CD integration. What is infrastructure as code, IAC, for Logic Apps? IAC involves defining Logic Apps resources, workflows, connections, integration accounts, in ARM, Bicep templates or Terraform. Enables consistent, repeatable deployments across dev, test, and prod environments. Recommended for production and team-based projects. How do you export a Logic app for deployment? In Azure Portal, go to the Logic app. Export template to download ARM JSON. Customize parameters for environment-specific values. Example, connection strings. Use the template in deployment scripts or pipelines. What is the recommended CI/CD approach for consumption Logic Apps? Use Azure DevOps or GitHub Actions pipelines. Store workflow JSON in Git, generate ARM templates, and deploy via Azure CLI, PowerShell tasks. Parameterize connections, integration accounts, and environment variables. How does CI/CD work for standard Logic Apps? Develop locally in VS Code with the Azure Logic Apps extension. Commit project files to Git repository. Use GitHub Actions or Azure DevOps to build and deploy the entire app to Azure. What are the key steps in a typical Logic Apps CI/CD pipeline? Source code commit in Git triggers the pipeline automatically. The build stage validates workflow definitions, connections, and syntax. The release stage deploys the template or app to the target environment using Azure CLI, ARM deployment tasks, or direct app publish. Post-deployment steps include smoke tests, health checks, and automated notifications. How do you handle connections in CI/CD deployments? Connections are environment-specific and should never be hard-coded in templates. Parameterize connection IDs, names, and authentication details in ARM, Bicep files. Use managed identities or Azure Key Vault references for secure credential management during deployment. What is the role of environments in Logic Apps deployments? Separate Azure resources, resource groups, logic apps, integration accounts are created for dev, test, UAT, and production environments. Each environment uses different connection strings, integration accounts, and scaling configurations. Parameter files, parameters, JSON, allow the same template to deploy consistently across all environments with environment-specific values. How do you monitor logic apps after deployment? Use the built-in runs history in the Azure portal to inspect individual workflow executions, including inputs, outputs, status, and duration. Enable diagnostic settings to send logs and metrics to Azure Monitor and Log Analytics for centralized, long-term monitoring. Create custom dashboards and queries in Log Analytics to track overall health and performance trends. What key metrics and alerts should you configure for logic apps? Important metrics include run success, failure percentage, total executions, average run duration, trigger latency, and action throttling events. Set up alerts for critical conditions such as failed runs exceeding a threshold, high latency, or repeated throttling occurrences. Configure action groups to send notifications via email, Microsoft Teams, SMS, or webhooks when alerts are triggered. How do you effectively debug failed workflow runs? Go to the runs history in the Azure portal, locate the failed run, and click into it to see a complete timeline of every action executed. Inspect the inputs and outputs of each action to identify where data became invalid or where an error occurred. Use the detailed error messages and stack traces provided, then resubmit the failed run directly from the portal after making corrections. What is the difference between resubmit and rerun in logic apps? Resubmit restarts the entire workflow from the beginning using the original trigger inputs and context. Rerun allows you to restart execution from a specific failed action while keeping the context and data from earlier successful steps. Both features are extremely useful for quick recovery and testing fixes without needing to trigger a new event. How do you implement versioning for logic apps workflows? For consumption workflows, maintain workflow JSON files in Git and use semantic versioning, example, v1.0.0, in commit messages or release tags. For standard logic apps, the entire project structure is version controlled in Git, allowing branching, tagging, and release notes. In CI/CD pipelines, associate deployments with specific Git tags or release versions for traceability and rollback capability. What are the most important best practices for secure deployments? Always use managed identities for authenticating to Azure services instead of storing keys or secrets. Store any remaining sensitive values in Azure Key Vault and reference them during deployment. Apply least privilege RBAC roles, use private endpoints, and scan deployment templates for security issues as part of the CI pipeline. How do you handle updates to live production workflows safely? Use blue-green deployment patterns, 2 parallel environments, or canary releases, gradual traffic shift, whenever possible to minimize risk. Thoroughly test all changes in non-production environments, dev, test, UAT, before scheduling production deployment. Disable workflows during planned maintenance windows if immediate changes are required, and always have a rollback plan documented. What tools and methods support automated testing for logic apps? The VS Code extension with Local Runner allows developers to run and test standard logic apps workflows locally using sample payloads. Integration tests can be written using Azure SDKs, REST API calls, or third-party tools to validate end-to-end behavior after deployment. Mock connectors, static sample inputs, and automated validation scripts help simulate real-world scenarios without affecting production systems. How does Azure Policy help with management and governance of Logic Apps? Azure Policy enforces organizational standards by requiring diagnostic settings, specific regions, naming conventions, or security configurations on all Logic Apps resources. It can audit and prevent non-compliant resource creation or modification automatically. Policies ensure consistent configuration, improve compliance posture, and reduce configuration drift across hundreds of Logic Apps instances. What is the role of Application Insights in advanced Logic Apps monitoring? Application Insights provides deep telemetry, end-to-end distributed tracing, dependency mapping, and performance profiling for Logic Apps workflows. It integrates natively with standard Logic Apps and can be enabled on consumption for selected scenarios. It is particularly useful for troubleshooting complex, multi-service integrations and identifying bottlenecks in high-volume production workloads. Describe a typical production management checklist for Azure Logic Apps. Enable comprehensive diagnostics and root logs, metrics to Azure Monitor plus log analytics immediately after deployment. Configure alerts for critical failures, performance degradation, and throttling events with appropriate notification channels. Regularly review run success rates, target greater than 99%, archive important logs, and backup integration accounts and certificates. Perform periodic security reviews, update access policies, and validate disaster recovery procedures. How do you scale management and monitoring for large numbers of Logic Apps? Organize resources logically using resource groups, subscriptions, tags, and naming conventions for easy filtering and management. Use a centralized log analytics workspace and Azure Monitor dashboards to aggregate data from hundreds or thousands of Logic Apps instances. Automate cleanup of old run history through retention policies and implement automated scaling rules for high-volume workloads. What are the most common pitfalls in deployment and management of Logic Apps? Hard-coding connection strings or secrets in templates, leading to failures when promoting across environments. Failing to set up proactive alerts and monitoring, resulting in undetected production issues for hours or days. Not having a documented rollback plan or version history, making recovery from failed deployments slow and risky. How have deployment and management practices evolved for Azure Logic Apps as of January 2026? GitHub Actions now includes more ready-made templates and better support for standard Logic Apps multi-workflow deployment. Bicep language has improved preview features for easier parameterization and modular templates. Enhanced integration with Azure DevOps provides stronger automated approval gates, compliance checks, and AI-assisted pipeline suggestions. Why is knowledge of CI/CD and management critical for Azure Logic Apps interviews and real projects? It demonstrates production readiness, DevOps maturity, and understanding of enterprise-scale operations beyond basic workflow creation. Interviewers frequently ask scenario-based questions such as, how would you deploy and monitor a critical Logic app in production? In real projects, poor deployment and management practices are the leading causes of downtime, compliance failures, and high operational costs. What is the recommended retention policy for workflow runs history and how should it be managed? The default retention period is 90 days, but this should be adjusted based on your organization's compliance, audit, and debugging requirements. Use Azure Monitor retention policies to archive critical logs longer, up to 2 years or more, while deleting routine run data to control storage costs. Balance the need for historical troubleshooting with storage cost management and regulatory obligations. Thank you for watching this detailed session on deployment, CICD, and management best practices for Azure Logic Apps. If you found this video helpful, please like, share, and subscribe to ZoomInData. More Azure Logic Apps interview and tutorial videos coming soon. Stay connected and keep learning.